Thank
Lisa,
you
do
to
you have
this
one?
group for coming.
You have
I
one?
hope that this session is very helpful for everybody.
Do you want apple juice?
It is entirely going to be on everybody's favorite word problems. Woo! All right. So, I know it's not the most fun subject, but it's going to be a key point at every grade level. I'm hoping today to answer any questions you guys have, show you a strategy for every problem at every grade level that makes it simple, intuitive, and is just helpful for you guys moving forward. All right. I give all my students in the sessions a chance to win a prize right off the bat. Here's your first question of the day. How many types of K2 word problems are there?
3. B. C.
It's A.
Who said B?
Me.
Incorrect.
It's A. It's
Who
A.
said A? Incorrect.
C.
No.
It is incorrect.
No.
None of them.
None of the above.
50.
Oh yeah, Dad, all of them together. That was bad.
So, it turns out there are actually 15 different types of word problems for K through 2, and most teachers don't know this. These are in the standards, these 15 types, and simply just knowing what these are to start is going to help you guys tremendously, even especially the K2 teachers. Just having your kids have had practice with the 15 types is going to make them so much better at word problems when they get a test and they've actually seen the questions on it before. So many times teachers are doing the 7 or 10 easiest types over and over, and they're missing those 5 or 7 hard ones, and the kids are never seeing them. And that's what happens. All right? I'm going to start you guys off with one problem. We're going to do a problem on your own before I start getting into all the modeling and stuff. You're going to turn to the third to last page. There's a problem at the top that begins with, a survey was given. Okay, so it's right before the page with the tables on it. Okay, I'm going to read it through one time, then you're going to do it on your own. A survey was given to a random group of people. 3/4 of the people answered that they liked their spouse. Of the people who liked their spouse, half answered that they have at least 1 drink per day. 6 people liked their spouse and had at least 1 drink per day. How many people took the survey?
Oh, yuck.
All right, get those brains going. On your own, try and solve this problem.
I haven't looked at a fraction in a long time.
This is a 4th grade problem. 4th grade.
Maybe that's because I don't like my spouse. I can't do this. It's the opposite part. Oh. Half.
Give it your best try.
Have at least 1 drink per day.
Did you get it?
Did you get in your head? I don't know. I'm one of those students that.
Okay, I'm thinking I got it wrong too, but I'm going with what did you
Okay.
get?
I don't.
Raise your hand if you're confident in your answer.
Matt, it's a 4th grade problem.
All right,
I need to move down.
here's the point.
I don't think you have enough information.
The point, believe it or not, is not to make you feel bad. It is to show you that basically all these word problems these kids are doing these days, they're getting more complicated, they're convoluted, there's a lot of information, it's very easy to make a mistake. It's very hard to even know where to start in these problems. I'm going to try and show you guys a model today that's not just going to work for some of the problems, it's going to work for all of the problems. Starting with kindergarten, all the way up into middle school, it's the same progression, it's the same model, so it's intuitive all the way. I want to show you how very complicated problems like this one, where a room of adults, most people have trouble with it, can become very simple if we start to see these problems in a certain way and make sense of it. Okay? All right, first step, we're gonna read the problem all the way through. To get context, a survey was given to a random group of people. 3/4 of the people answered that they liked their spouse. Of the people who liked their spouse, half had at least 1 drink per day. 6 people liked their spouse and had at least 1 drink per day. How many people took the survey? In our session today, I'm gonna ask you to start to think of a number as just a bar. We're gonna represent it as a length, okay? A survey was given to a random group of people. Who or what is this problem about? It is about people. We're gonna write what we're dealing with here, okay? We're gonna make our little starting line, like always. And now, again, today in all these problems, I just want you to start to think of a number can be represented just as a bar. A survey was given to a random group of people. There's my random group of people. We okay with that so far? Mm-hmm. We're just saying, there's my length. 3/4 of the people answered that they liked their spouse. Hey, 4th grader, can you show me fourths? You think they could do that, a lot of them? They go, yeah, I can show you fourths. There's fourths. Well, 3 out of 4 pieces, 3/4 of the people answered that they liked their spouse. 4th grader, can you show me 3 of those pieces? Sure. There's 3. Liked their spouse. Yay. Smiley face. Of the people that liked their spouse, half answered that they have at least 1 drink per day. We're dealing with just the people that like their spouse, so you know what we're going to do in these harder problems? We're going to drop it down, and we're going to work with a new whole. All we're saying is we're taking that amount of people that like their spouse. There's my new whole. Hey, 4th grader, can you show me half? It says half of them had at least 1 drink per day. They go, yeah. There's half. Here's my martini glass. There's 1 drink per day. Good so far? Last sentence says 6 people liked their spouse and had at least 1 drink per day. Isn't that my 6 right there? Right? That's what it's saying. It's saying 6 people liked their spouse and had at least 1 drink per day. Oh, 4th grader, if that piece is 6, what's the piece next to it have to be? 6. What's my total bar have to be down there? 12, right? Isn't that whole length have to be 12? They could show you that. Oh, 4th grader, can you think of 3 equal parts that make my 12? What would have to be in there? 4.
Oh, I got it wrong.
4. Oh, if those are 4, what does the last part have to be? 4. How many people took this survey?
16.
And they can see clearly, oh, has to be 16.
I got it wrong. I have 21.
Okay, again, it's not to say that this problem is going to be given at your grade level if you teach a different grade. I just want to show you the power of these models that have come out, not recently, but that people think are recent, that just make these problems so easy to do, and they're intuitive. This is not some trick I'm going to come in here and show you that only works for a handful of problems. It's a strategy, and I'm going to try and show that to you today. So, the most common type of solving word problem strategy I see out there is that cubes method. Okay? I won't ask who uses it in here, but most of the district workshops I do, almost everyone does it. It's a method of you go through, you circle the numbers, you look for the keyword, you box or highlight the keyword, you underline the question, something along those lines, and you cross out miscellaneous information. That is following a formula. They're literally, the kids are following a formula, and most of the time they're getting it wrong, and I'm going to show you the types of problems that they end up getting wrong. Okay? So, here's your typical bar model for a 4th grade fractions problem. We're going to show you how it works from the beginning. All right? All right, let's go ahead, turn back to the beginning. Okay, we're going to start nice and easy. We'll start in K1. We'll go through it quickly, and we'll move on up. It's going to be important, again, to see the progression of the models, even if this is not in your grade level. First question, I'm going to read it through one time to get context. Leah picked 5 apples. Luke gave her 7 more. How many apples does Leah have now? Who's this problem about?
Leia.
And who are they from? Star Wars! Who said it? In the back, correct.
I've never seen Star Wars.
All right. Here's going to be quickly kind of our 6-step method for solving it, okay? This doesn't, it's really important for the beginning. In the later grades, not as important, we can skip some steps. We're gonna read the entire problem through to get context. Why do we do that? Half the time, kids start reading the problem, they start doing stuff right away before knowing the entire problem. By the time they're done, they've solved for the wrong variable. Happens all the time. Number 2, we're gonna rewrite the question as a statement. Again, this is only for the beginning. Why do we do that? It's, again, to double check that we're getting the right thing. So after we solve it all, we can go and check, did we even solve for the right thing? Number 3, determine who or what this is about. What's the countable thing we're getting information about? Number 4, we're gonna draw the model. I'm gonna show you all the different models today. It's really the same model, it just changes for every grade. Solve your equations and check your answer, meaning is it reasonable? First problem, lay and leave. In K, we're gonna start with the part total model. I'm not gonna spend a lot of time on it because I wanna get into the models for the older grades. Here's what it's gonna look like. Real quick, do we have any K teachers in here? I just don't wanna spend too much time, okay. Here's your part total model that I suggest you start with in K and 1. Your total is gonna be the bigger piece. Here's one of your parts. Here's your other part. Leah picked 5 apples. Luke gave her 7 more. How many apples does Leah have now? What would my question be in the form of a statement? How many apples does Leah have now? Leah
Has blank apples.
In the early grades, it's going to be helpful just to do the step. They can check, am I solving for the right thing after I do all this? Leah picked 5 apples, Luke gave her some more. Is 5 apples some of the apples or all of the apples? Some. That's going to go in my part. Luke gave her 7 more. Is 7 more part or all of the apples?
Part.
There's my more. How many apples does Leah have now? Up here, we're going to make a question mark. And in the very early grades in kindergarten, before they know the numbers, we can use counters. We can use unifix cubes. You can put those numbers in the spots and move them to the different areas so that they can see what the numbers are before they know how to write them. Okay, here's our equation. We see clearly 5 plus 7 equals what? Let's do the next one quickly. There are 8 bananas all together. Tammy uses 6 to make banana bread. How many bananas are left? There are blank bananas left. Oh, I can check by the time I'm done, did I solve for the right thing? I would say in grade 2, you can start to omit this step. Once they've had practice with this, they don't need to keep doing this. There are 8 bananas all together. Is that some of the bananas or all of them? It's all. I'm going to draw our model. Oh, it's all. And I'm going to label it all. Tammy uses 6 to make banana bread. There's my part or my change. Right here, you can label it as part or change. How many bananas are left? And from my diagram, I can see what plus 6 equals 8. 8 minus 6 equals what? It's both. These problems, so many teachers label their problems when they're giving them as addition problems. Here are your addition word problems. Here are your subtraction word problems. Multiplication, division, it's not like that anymore. It changes the operation based on the context of the problem. So if you're labeling them as operation specific, I wouldn't do that. A, you're already suggesting an operation when it might not be the best operation to use for that problem. We have joining problems instead of addition, or we have separating problems instead of subtraction. Okay? Last one we're going to do for K with the part total method. So just to let you know, K in the standards, K is responsible for 4 different types of word problems. They have to know 4. It is in your packet. Okay, I have a table that I put in there, the 15 types that I mentioned at the beginning. Where are my tables?
Yeah.
Here are your 15 types. So if you're a grades K through 2 teacher, look up here real quick. K, you have to know problem types 1, 4, 7, and 9 in your sheet on your table. Grade 1, believe it or not, in the standards says you have to know all 15 types, but it's unreasonable. It's too much content. So because it's early, what I tell schools is really the ones you need to focus on and make sure they know by the end of the year are these in orange. Number 2, 5, 8, 10, 11, 13, 15. Grade 1, those are imperative that you know by the end of your grade. Then grade 2, you are, again, you're responsible for all 15, but the important ones, number 3, number 6, number 12, and number 14. Okay, so you'll have this table to refer to anytime you're confused. These are the different problem, the 15 different problem types. Okay, then we're just going to get back to our last K problem, then we'll move on. There are 4 cats and 5 dogs waiting to be adopted. How many animals are there in all? There are blank animals in all. We have our part total. There are 4 cats and 5 dogs. Are 4 cats all the animals or some of the animals? Some. There's my part. It's some. Oh, the 5 dogs is some. And what are we looking for? We're looking for all. The all or the total is always going to go in the top because that box is the sum of the 2 below it. And the kid can see that. We have a model that is intuitive. We're looking for the all. Oh, my equation, 4 plus 5 equals 4. This is going to cover you for every single type of word problem there is in Canada. This model, it's always the same as long as we can figure out what is the all, what are the parts. Okay, moving on. Now we're going to get into really the bar model and the same model that's now going to be used for the next 6 years. Okay, turn the page to their next problem. Kendall had 19 photos. Kylie gave her some more. Now she has 35 photos altogether. How many photos did Kylie give Kendall? Who's this problem about? The Jenners. Very good. Okay, I'm going to show you how to
Aren't
do
you surprised I knew that? I watch a little trashy TV sometimes.
Okay, here's how we're going to model all of our problems basically for the next 5 years. Who or what is this problem about? What's the countable thing? Photos. This problem's about photos. We're going to write photos with our starting line. Okay, so go ahead and do that. Again, we're going to start to think about numbers as a bar. That's it. That's the only transition we're going to make. We're just going to start to think of it as an amount. Okay? Kendall had 19 photos. Kylie gave her some more. Is 19 photos some of them or all of them? Some. Can you show me a bar for 19? Kendall had 19 photos. There's my 19. I'm just going to call it a bar. Kylie gave her some more. Does my bar get longer or shorter? Longer. It's going to get longer. I don't know how many more. There's my more. Oh, now she had 35 photos all together. Well, the total length of my bar, I'm saying my whole bar, has to be 35. How many photos did Kylie give Kendall? And this diagram basically gives you the equation out of it. 19 plus what? Equals 35. Every addition subtraction problem is going to look like this in all of K1 and 2. Okay, before we get to comparisons, you're going to have a part, you're going to have a change, and you're going to have a total. And this method, this model, is going to clearly show that in a way that's intuitive, that organizes the information well, and prevents mistakes. Let's do one more.
Do you stop writing the statement for this? Like, do you only do that for kindergarten when you
I would do it as long as the kid needs it.
Okay.
Until the kid is getting the problem right without needing it, I would keep doing it. And then, yeah, at some point you can omit that.
But for like engage, then they'd write that statement at the end. That
They
right
write at the
step.
end.
Yes.
I always have schools write it at the beginning because it's like, that's the point of the question, right? You have to know what you're solving for before you start. What happens too many times is you write it at the end. Well, say the kid did out the problem and they solved for the wrong thing. You know what I mean? Then they did all that work solving for the wrong thing, and now you have the question at the end, when if you had it at the beginning, you can check that. So I guess, I would.
So then
tend
it
to
would
do
be
at the beginning.
read, write,
Yeah.
draw,
So it would be write, read.
write,
Read, write,
draw, write, because equation.
Okay, let's do one more. Simple, these are first grade type problems. Tara had 21 snails in her bucket. Some of the snails crawled out. There are 7 snails left. How many snails crawled out? Well, who or what is this problem about? It's about snails. And I draw my starting line. Again, we know what the problem is about. A lot of these methods, you go through circling, crossing out, underlining stuff, you have no idea what the problem is about when you see the kids work. It's about snails. Tara had 21 and some crawled out. Is 21 all of them or part of them?
All of them.
It's all of them. She had 21. Okay, there's my 21. There's my all. And some crawled out. If some crawled out, does my bar get shorter or longer? Shorter. Crawled out. Some crawled out. Now there are 7 snails left. 7 left. Again, they don't even have to come up with the equation. The model is giving it to you. We have 7 plus what equals 21. And now we get a different part of the equation being unknown. Same model will work for every type of addition subtraction problem in all of K1, 2. Okay? Good so far? Any
It makes
questions?
those bar diagrams that, you've all of a sudden have and engage, have a purpose to them.
Okay, now we're going to get a little bit harder. Okay? We introduce comparison problems. We introduce additive comparison problems. Kevin scored 92 goals and Connor scored 75. How many more goals did Kevin score than Connor? This is now a different type of problem. We're not saying there were some amount of goals and some more goals were added. Now how many goals? We're saying there was some amount of this goals and some amount of this goals. What's the difference between them? Okay? Only difference is now there's 2 things instead of 1. Okay? So when we say who or what is this about? It's about Kevin's goals and Connor's goals. And we draw our starting line. It's the same thing.
Would you point out then that it's the comparison?
Yes,
versus the other one?
very important that when you start to do comparisons, you point it out because now you're getting information about 2 different things rather than 1. It's a big step, big change. Okay, I would even, when you identify that it is a compare problem, I would even write in the corner of the problem, compare. Compare, and then you underline it and you know, okay, this is a compare type problem. Same thing's gonna happen with multiplication division later. Okay, but no big deal. The model's gonna be the same. It's gonna be consistent with everything we've been doing. Oh, do I know how many goals Kevin scored? 92. So let's draw a bar for 92. Simple. That's what we always do. We're just saying, there's my 92. We're representing numbers as a bar. Connor scored 75. So we can draw Connor's, right? Does it have to be shorter or longer? Shorter. It's gotta be shorter. So let's just draw a bar for 75. How many more goals did Kevin score than Connor? You know what's always gonna be the difference? This guy right here. That difference between the 2 bars, whether the question asks for more or fewer and the kid's getting all confused. Now, I'm not saying it's not important to recognize and know the difference because they have to, but guess what? When they do the model, they're never gonna make that mistake of adding when they're supposed to subtract, subtracting when they're supposed to add, because the difference is always right there, always. There's your more. The only other type they're ever gonna ask is, how many goals did they have all together? In which case, we're just gonna add them. Those are the only type of comparison problems in all of grades 1 and 2. Let's do one more simple one, and then I'm gonna have you do some on your own. Let's go to the next one. Ross read 78 books, and Rachel read 93. How many fewer books did Ross read than Rachel? What are we talking about? Friends. Ross, Rachel. You could put books. You could put Ross's books, Rachel's books, and we have our starting line. This is a compare. It gave us two different things. It gave us Ross's books and Rachel's books. It didn't say Ross had 78. Rachel gave him 10 more. Now how many does he have? That would be one thing. It's saying Ross had 78, Rachel had 93. Oh, can you show me Ross having 78? Sure. Easy. Oh, second grader, can you show me Rachel having 93? Does the bar have to be bigger or smaller? It's gotta be bigger. There's my 93. How many fewer books did Ross read than Rachel? How many more books did Rachel read than Ross? Doesn't matter what they ask. Here is your difference, right here. There's your fewer. Oh, do you see an equation from this? Yeah, 78 plus what is 93? Or 93 minus 78 is what? If I said, how many books does Ross and Rachel have all together? We would add them. And there would be my total. Are we good so far? Because we're going to get harder. This is just the beginning. Turn to the next page. We're going to do the problem with ducks. Here's where people get into big problems, the teachers that use the cubes method. Okay? I know there's lots of different acronyms. This is directly from Scholastic's website, how I got to this page. The most common way I see teachers teaching word problems is the circling, underlining, and keyword method. It looks like this. This is what they're telling you to do. Okay? So cube stands for circle the numbers, underline important words, box the question, eliminate unnecessary information. It's the #1 method I see. Here's the vocabulary signpost table. They list the words, the keywords to look for. Oh, I see more than, that's an addition problem. I see fewer or fewer than, that's a subtraction problem. And the kids get used to using this table and looking for associations based on their keywords. Let's go back to our problem and show you what happens when the teachers don't realize the 15 different types and they're only doing the 7 easiest. Let's try the cubes method. Karen has 41 ducks. Oh, I look for a number, I circle it. She has 18 more ducks than chickens. Ooh, my keyword. There's more. How many chickens does Karen have? There's my question. I underline and I eliminate unnecessary information. This is following the formula, and it's probably the most common type of solving word problems out there, not making sense of it. And we see the kid can follow your directions perfectly, and they get 41. Oh, I see more. I add. It was in my addition table. 18 equals 59, and they're all happy. And this is what's out there. That table I showed you was literally, I got it there from Scholastic's website. Let's see what really happened in this problem. So the kid follows the directions perfectly, looks for the association. Karen has 41 ducks. She has 18 more ducks than chickens. Oh, this is a compare problem. Oh, I can do these. I've done tons of them. I've done a whole year's worth already in first grade. What is this problem about? It's about ducks and chickens. So we put ducks and chickens like we always do. Oh, that's what this problem is about. Yep. Karen has 41 ducks. Second grader, can you show me 41 ducks? Sure. Here's my 41. Right there. She has more ducks than chickens. If I look at that and the problem says she has more ducks, does the ducks bar have to be bigger or smaller than the chickens?
Bigger.
Bigger. It's saying there's more ducks. So doesn't my chickens bar have to be smaller? Isn't that what that means? Oh yeah, there's more ducks. How many more? Where do I always know my more or fewer is, that difference? Isn't it right here? Oh, there's 18 more. And it's the same comparison problem that I've been working on. And what's my equation that I see? Oh, what plus 18 is 41? Guess what the answer is? Didn't this turn into a subtraction problem? Didn't our number get smaller? But what happened? We saw more. More is one of the addition keywords. It got smaller. More or more than, I can give you problems that are subtraction. More and more than, I can give you problems that are addition. Fewer and fewer than, I can give you problems that are subtraction and addition. We're going to get into big, big trouble if you start to associate keywords with operations because it doesn't work. And what ends up happening is a lot of the teachers, they don't know the harder problem types, so they're never seeing those problems. And all the problems they do it for, it always works because they're not doing the 7 harder problem types where the word means the opposite from what people are used to. But if you draw out the model this way, very hard to make a mistake, especially if we've been doing our method that they've been working on. And we're just making sense of the problem. We're trying to make a model that says, okay, here's what this problem is about. I'm comparing 2 things. I was given some amount of one, and I was not given some amount of the other, but I knew the difference. What does that other piece have to be? And if they can do this, it's really going to help them. Okay? There's going to be my more. And I'm used to this again, if I'm the kid, because I've been doing these problems with this model, hopefully for the entire year before I even get these problems. Okay? We're going to do one more. This time I'm going to let you guys do it on your own. The next problem, this is a fewer than problem, again, where the word means the opposite of what you think.
Well, that just told us we did what?
All right, Paige planted 36 peach trees. She planted 12 fewer peach trees than apple trees. How many apple trees did she plant? Who or what is this problem about? Peach trees and apple trees. It's a compare. Let's give it a both. Oh, no big deal. It's about peach trees and apple trees. Do we know how many peach trees? Yep. There are 36 peach trees. She planted 12 fewer peach trees than apple trees. If I said, looking up there, I said there are fewer peach trees, doesn't my apple trees have to be longer? If I'm saying there's fewer peach trees? Yeah. There's fewer peach trees. And I go back, I check, is this reasonable? Yeah. If I draw those bars, if I drew this bar, and I get confused because these problems are hard, and I draw it like that, and I think to myself, is that fewer peach trees than apple trees? No, there's got to be more peach trees there. So you know what I know? This one's got to be longer. Now my model's saying there are fewer peach trees. How many fewer? Oh, I've been doing fewer and more for the last year. That's easy. There's my fewer, and there's my 12. How many apple trees did she plant? Oh, I look at my model. Do I see an equation? Yeah. 36 plus 12 equals what? Notice, wasn't this an addition, end up being an addition problem? Did the number get bigger? But what happened? If I had done the cubes method, I see 36, I see 12, I see my keyword fewer. What do I always know fewer means? Subtract. The tables online tell you to do that. I underline my question. Oh, 36 minus 12, fewer. I would get 24, but guess what? 24 is not the right answer. And guess when they get the test, guess what is going to be option A in multiple choice?
24.
24 every single time the test people make that number one question, 24, because they're going to see fewer. And every single kid is going to get it wrong. So we're trying to make sense of the problem using a model that is intuitive. All right, I'm about to jump now into grade 3, multiplication division. Do we have any questions so far in these basic kind of straightforward ones?
Can handle that?
I just have a question, because in our curriculum, like with EHD, right, like it introduces us, I teach first grade, and it introduces it like at the end of the year.
Yes.
Do it sooner?
It's your call. So the part total
Like
method,
developmentally,
Yeah.
like, they draw the circles for a long time.
it's really up to you. I tell teachers to make the switch whenever they feel their kids are ready. To me, I feel like the original bar model we did,
Yeah,
this one,
like the kids.
is almost just as easy to learn as the part total to me, but so I tell teachers to do it, as soon as they can to make that jump. But if you need to stay with the part total method for all of first, that's okay too. I would say second grade is really the grade where you have to move from the part total. We got to start doing this model. This is the one that they're going to use for the rest of elementary school.
So
And
stop drawing.
Good answer.
the circles is great for arithmetic. When you're doing number bonds, it's great for that because you're showing that two parts can make that.
Well, I mean, like when you solve it and you're like, okay, there are 4, so draw 4 circles, and then there are 5 more, so now I have 5 circles.
Oh, that's different. That's a different question. So that really has to do more with the arithmetic. Can they handle the numbers yet? If they're not ready for the numbers, stick with that for sure. I'm talking about more as when it gets to word problems.
Right.
How do you go about that? If they're not on to digits yet, you have to stay with the counters until they understand. Yeah. That's more of like kind of a separate arithmetic thing that you have to do with them outside of the word problems.
That's a computation
Yeah,
as opposed.
computation, really, yeah.
Okay.
So
That's your fluency as opposed to your understanding of.
exactly.
Bare numbers as opposed to in context.
Exactly.
Got it.
So yeah, even if you are doing the word problems, if you have to, and we're doing the part total method, I tell a lot of teachers that aren't ready for using digits, use unifix cubes.
Right.
Just like what you're saying, the circles, if it said there was 2 apples, Tina gave him 3 more, put 2 in the part and put 3. And tell me, oh, how many cubes do you see all together? And they can move 5 into the top one.
Yep.
Totally fine. Okay. So, hopefully in first and second, we have this model when we're dealing with one thing. Again, very straightforward. The only thing that we add down the road is we have a compare. We're just saying now there are 2 things instead of 1. No big deal, works the exact same way. Third grade comes along, now we have a new operation. But you know what? Our model is going to be exactly the same. All the same we've been working on. Our convention in the US is the number of groups times the size or the value of each group equals the product of the total. It is important to realize the difference. Okay, the number of groups comes first. That is just our convention in the US. It's important for you to understand this as teachers and for your kids to understand it. 5 bags with 3 jelly beans in each bag is not the same as 3 bags with 5 jelly beans in each. They are totally different, even though you're getting the same answer. When they have to do these problems, they have to make the distinction between both. It's the number of groups times the size or the value of each group. Steph scores 7 points per quarter on average. In 15 quarters, how many points will Steph have? What is the group here? Is it the quarter or is it the 7 points per quarter? What's my group in this context? It's the quarters, right? And what's the value of each group? 7 points, okay? Here's how we're gonna do all the multiplication division problems. Who or what is this problem about? It's about points. Same as always, that's the thing that we're getting information about. And we draw our starting line. Now, we know there's 15 groups. In this case, it happens to be quarters. It could be bags. It could be vans full of kids, whatever it is. There's 15 groups, and there's 7 points per group. There's group 1. There's group 2. That's worth 7. There's group 3. There's group 4. Here's group 5. Anyone want me to stop? There's group 6, so on and so forth. And
I'd
at
like
the
to
beginning,
go home.
when you're doing simple multiplication with them and you need to show them, I would draw out all the groups. So when you're doing very simple problems, 3 times 2, 4 times 5, draw out the groups so that they can see, yeah, what is multiplication? It's all, I'm adding together all of these equal groups, and I'm looking for, again, the full bar, just like we've been doing for the previous 2 years. Same thing, my full bar is the total. Down the road, here's what's going to happen. The numbers are going to get higher, and there's too many groups to draw. So you know what our shortcut is going to be? We're going to draw group 1 and group 2. All the groups in the middle, we're just going to write dot, dot, dot. And we're going to make our last group, in this case, group 15. Okay, so whether the groups was 47, 150, whatever, we're just saying here's group 1, group 2, all the groups leading up to it, and here's the last group, and what's my total? Oh, that's what I'm looking for here. How many points will Steph have? Here is the number of groups down there. Here is the size of each group. Here is the total. 15 times 7. I should say 15 groups of 7 equals what? And this model is going to take you through every multiplication division problem encountered in third. Okay, let's try another one. Let's go to the one right below. Okay, now a different variable is missing. There are 63 students in the school's marching band. To go to the game, they divide themselves equally among 9 bands. How many students ride in each band? Who or what is this problem about?
Students.
Students. Good. And we write students just like we've been doing. There are 63 students in the marching band. To go to the game, they divide themselves equally among 9 bands. How many students ride in each van? Well, there's van 1, there's van 2, these are my groups. Here are all the vans in the middle, and what do we know? You know, there's 9 vans altogether. There's 9 groups. Do we know the size or value of each group? No, that's what we're looking for. How many students ride in each? But what do we know? There are 63 students altogether. The number of groups times the size of each group equals the total. And again, we have a model that is intuitive, that helps us organize the information and makes problem solving simple and makes the risk of making a mistake way down. Number of groups, oh, that's always going to be on the bottom, 9. Groups of something equals 60. Or 63 divided by 9 equals what? And that's why we don't label them as operation specific. It's both. Good so far? Any questions about this? So again, we try and make a model that easily progresses from one year to the next. It's not a big change from what they've been seeing, and it still helps us solve these so effectively. Now, we're going to get really hard.
Before we get really hard, can you just quickly ask?
Yes.
So beginning of 3rd grade, they're introducing multiplication. Would you hold off on like this method for solving word problems because they want to use the array, like drawing the array to visualize it?
That is totally fine. At the very end, I'm going to go over the progression of content by
Okay.
quarter, and that'll help answer that question.
Okay, sounds good.
Okay.
Thank you.
All right. Now, 4th grade comes along, and you know what's introduced? Multiplicative comparison. Now these are getting fun. Okay, flip the page. You're going to start with the question that says over the weekend. Okay? Over the weekend, Edward and Bella slept a total of 52 hours. Bella slept 3 times as much as Edward. How many fewer hours did Edward sleep than Bella? What's this about?
Sleep.
Twilight.
That one I did.
Okay?
I didn't know.
Try this on your own. Okay, here's going to be the next progression after the multiplication division problems. This is a pretty tough problem for most people, but if we stick with our method, okay, it just makes sense of it. We're trying to make sense of the problem and use an intuitive model. It's going to be very, very easy. So again, I want to just give you some hints. When you're doing this, think, who or what is this about? Is it a compare problem? Are you getting information about two different things? If so, think about, logically, and just make sense of it. What do the bars have to look like? Well, we know we represent numbers as bars when we're doing these. What do those bars have to look like? Use the information you know. You're not given specific numbers in this one, but that's okay.
I wish I could sleep that long.
Does your mom like mine?
Did I goof?
Oh no. Oh, I just did something. But yeah.
Over the weekend, Edward and Bella slept a total of 52 hours. Bella
Okay.
slept 3
I
times.
see a lot of people doing it exactly correct, but they're getting a little stuck. Over the weekend, Edward and Bella slept a total of 52 hours. Bella slept 3 times as much as Edward. How many fewer hours did Edward sleep? Oh, who or what is this problem about? It's about Edward's sleep and Bella's, right? Edward and Bella, and we draw our starting line, like always. It's a compare problem. But now we're doing multiplicative comparison, not addition, subtraction anymore. Bella slept 3 times as much as Edward. Hey, 4th grader, could you show me Bella being 3 times Edward? Maybe not on the first time, but eventually, if you said, that's Edward, can you show me 3 times that for Bella? Wouldn't it have to be 3 of those? 2, 3? And after you show them this 1 or 2 times, couldn't they pretty much tell you that, whatever you ask them going forward? Can you show me this times as many? Yeah. What do we know? They slept 52 altogether. Are all 4 of those bars equal up there?
Yeah.
Aren't they? You have 52 altogether. Wouldn't it just be 52 divided by 4?
Or
Don't
4
we
times
know?
blank.
4 times what, exactly? And doesn't each bar just become 13? And we can see intuitively,
Oh, we didn't
yeah,
try this part.
Bella's is
We forgot this
clearly
part.
3 times Edward. It's 3 times
Because
in
this
length
is what we're
by
looking for.
pieces and the number,
No.
right? We have 39
Here we
here
are.
and we have 13
Oh,
there.
you're right.
And that problem, after you give this a couple times, becomes very simple. Very simple. If I
I'm
give you
stuck
this
on
again.
division. Haven't done
Don't
that
you
in a
have do up by Edward? Should there be a dotted box because that's what we're trying to find with a question mark?
What? Say it again.
Up by Edward, should there
Yeah.
be a dotted box with a question mark? Because that's what we're trying to find.
You could. Yep. I'm kind of skipping ahead. But
Yeah, I'm
this-
just thinking
yeah,
of that
exactly.
change,
You
going
could-
back to that other.
At this point, once they're a
I
little
didn't
bit
have it in
older,
there.
4th grade, you could do the box, or at this point, they should really be able to tell if you said, where's the more? They should be able to show you, that's the more. It's already there.
Great.
In a younger age, they still need to make that, you've got to show them the gap. Hopefully, by the time they've done this now for 4 years in the early grades, they can just tell you, there's the more. But if you wanted to still do the box, that's fine. Right?
Now, on a lot of the tests where it says, explain your thinking, is that enough to, the diagram, would that be enough to explain the thinking, or would they also have to write that all out in words?
I mean, in my personal opinion, that's plenty, right? This is the thinking. You cannot get any more intuitive than this. You're telling them exactly that that's what you're comparing. You're showing them what the problem told you is the ratio and proportions, and you're telling them the exact amount of both, and then you're showing the difference. I don't know, like, technically, if that counts on the test that teachers give.
A lot
but
of them,
to
they
me-
say use, what does it say, use pictures or explanation.
This,
And I think
this
they
is more
use
intuitive than
both.
any
Yeah.
explanation I can think of.
And I
Giving
think
you
some of
notes.
our kids get hung up because they don't like to write step by step what they
Well, yeah,
did.
I think with us it's fine, but like I'm thinking of like the state testing, like somebody who grades that who doesn't know the kids, doesn't know that type of thing.
They
Well,
get
that-
points for explanations on those state tests?
So the state test is kind of like a 3-2-1 or
Okay.
like a 4-3-2-1 type of concept.
I mean, I don't know how to help with that if you
Yeah.
want to write out the steps, but in terms of solving the problem, if
Mhm.
I saw that,
Right.
I would know that the kid inside and out understood the problem thoroughly, or else those pieces would be wrong. You know what I mean?
Mm-hmm.
Yeah, that should be.
So, we'll see. Try the next one on your own. Kim is twice as old as Chloe. Courtney is twice as old as Kim. If the combined age of all three girls is 63, how old is Chloe? Now, you have a three-part problem. So we've made it harder again. No big deal. Think, who or what is this problem about? And now instead of two things, we have to compare with three things. We're just going to make sense of the problem.
Kim is twice as old as Chloe. Oh, shoot. Courtney is twice as old as Kim. I didn't know Courtney was older. I don't know anything about the Kardashians.
You're not really wondering.
Not really. I don't. Yeah. Kim's got the big butt, but. How old is Chloe? So we want to know this one. Oops, shoot. 1, 2, 3, 4, 5, 6, 7, 9. Each one is 9. I don't know my multiplication.
Okay? Since we're pressed for time, we're going to go a little quick here just for the sake of time so we can get through what we need to. Okay? Kim is twice as old as Chloe. Courtney is twice as old as Kim. Who or what is this problem about? Oh, it's about Kim's age, Chloe's, and Courtney. No big deal. We have a compare, but we were given three things. Kim is twice as old as Chloe. Fourth grader, can you show me Kim being twice as old as Chloe now that we've done a bunch of these? They go, yeah, no problem. That's got to be Kim twice as old as Chloe. It's pretty easy. Oh, Courtney is twice as old as Kim. Well, if Kim is 2 bars, how many bars does Courtney have to be?
But you can see how many of the
4.
state problems.
And the kid draws 4 bars. Yeah, that makes sense. The combined age of all 3 girls is 63. How many equal bars do I have? 7. 63 divided by 7 is 9. And each bar has to be 9. Oh, is it easy to tell what's Kim's age? Easy. Kim's got to be 18. Is it easy to tell what Courtney's age is? Easy. Has to be 36.
Oh, I goofed. I made Chloe 36. Because I added the 27, I put the top off. I'm out of here.
All right. So again, in all of what we're doing, again, I'm not showing you this as some trick or anything, or that you want kids to solve it like this all the way up until they're adults. The point is that so many times, A, we don't have a strategy for organizing this information properly, and we're missing out on the number sense part and the just making sense of the problem, and we're jumping to algorithms too quickly. And the kids are going right into lining up subtraction problems, or right into lining up division problems and doing it the long way. And they're not understanding what's going on. Learning the algorithm, following a formula is the easy part, not the other way around. The understanding is the important part, and we're skipping over it. If they learn this and they get this, doing the algorithm when they need a more efficient, faster way to do it is easy. That all makes sense at that point. But when we jump to that too soon and they miss out on the understanding, that's when they get lost for the rest of math. All through middle school, they're playing catch up. They're just trying to remember, okay, what was that formula I was supposed to use on this type of problem? And they're getting themselves confused and the understanding is gone. So if we can use a model like this from the beginning that shows you how to do each problem intuitively, when you get to the formula and you want them to do it more efficiently, very, very simple. Okay? All right, I have some harder problems in there, but I'll spare you guys for today. Okay?
Math,
Any
it's your homework
questions
for
so
tonight,
far
you
at
must
all that I
answer
can
all of them.
answer? I want to show you one more thing. I'm very proud of this. I'm the only person that I know that I've ever seen do this out of all the presenters. There's your progression. Okay?
Do we have that?
Here's your progression. It's not in there. I don't put it in the packet yet. You guys can copy it if you want. But look at how simple and seamless this is when we use this. Here was your basic addition subtraction starting in 1st, 2nd grade. we're dealing with one thing, we're saying 2 parts in our total. Remember all those problems we did? That covers all the problems in 1st grade and 2nd grade, all of them. Then later, we introduce additive comparison, okay? The only thing that changed, they're already used to doing tons of problems like this. We just added 2 things, no big deal, but we're comparing 2 different things, still representing it as bars. There's the difference. It's gonna be hard to make mistakes as opposed to that other cubes method. 3rd grade rolls around. Oh, we have the same exact model, but it's a little bit different because now we're dealing with equal groups and there's a lot of these, but the model is very similar. Again, I did now 2 years of this. That changes nothing. After 3rd grade, we introduce multiplicative comparison. Sorry, I'll go down here. Same thing. We're doing multiplication, but now we're comparing 2 things. It's okay, I'm used to it. And then later we do fractions. I didn't get into enough fractions problems today, but you saw that one at the beginning. Again, very easy. We're just saying, here's the total, it's a bar. Here's my parts. Oh, if I have to deal with a new whole, I drop it down. Here's my parts. It's easy to go through and solve. There's your progression for all of elementary school.
Can you send me that?
Yes.
Thank you. So Matt, you can stop drawing on.
Okay.
He's gonna send me it.
So, I tried to give you a way
I thought you were-
today.
Oh.
Again, that's hopefully it's helpful. Again, my goal is not to tell you you have to do it this way. I would say choose for yourself. You know what I mean? You know how it's being done. You know how you approach those problems today. You know, make your own decision. Is that a more helpful way to do it? Is that explaining things better? Do you think your kids would understand that better? And keep in mind, moving to the algorithm is the easy part, not the other way around, which is the common misconception. Anyone can learn an algorithm and follow a recipe. You know, a really good cook, what do they not need? They don't need the recipe, right? That's why we call them a good cook.
I'll never be that cook.
All right?